Okay, so welcome to this video on 10.3, and we might even get into 10.4. What we're doing is the division property of exponents. So like, we know that if we multiply exponents, we keep the base and we add the exponents. So if we think about it this way, I just want to do a quick little thing here. We know if we're multiplying powers, right? We know that we're going to keep the base and we're going to add the exponents. Well, what's kind of cool is that we know that the opposite of multiplication is division. So if we're dividing powers, we're going to keep the base still. But what would be the opposite here? Subtract the exponents. So we know that we're doing the opposite. This is subtract abbreviated. We're doing the opposite of multiplication, so we're going to do the opposite of addition. So the opposite of multiplication is division, right? So these are opposites. And we know that the opposite of addition is subtraction. So math kind of makes some sense in that way, that the opposite operation for exponents, you use the opposite operation. Or I guess the opposite operation for powers, you use the opposite operation for the exponent. So let's like simplify these problems out, try to think about what we're doing here. I would like to make this into just one fraction where the tops are all multiplied. Multiplying fractions, no big problem. Top times top, bottom times bottom. I like to think about if there's anything I could cancel, just to kind of help you to understand what's going on here. Do you see anything that would cancel? We don't have to cancel things, but I think it might be cool to do that. Yes? So that would cancel with that, 2 to the third and 2 to the third. 2 to the second would cancel with 2 to the second. So we'd be left with 2 to the fourth divided by 2 to the, well, there's no power there, so what power would be there, you think? What exponent would be there? Yes? 1. To the power of 1, exactly. So we just wrote this down. We keep the base and we subtract the exponents. So what do you think the answer is going to be? 2 to the third power. Now, another way we could do that is we could write out 2 to the fourth, which is 4 2's. We could write out 2 to the first, and we could again cancel one of them out. We can also just say 2 to the 4 minus 1. If we just take that and subtract them, that's 2 to the third. Isn't this also 2 to the third? So you can get the answer in multiple ways. Yes? Sure. So what we're going to do now on the second problem is we're going to try that same thing, but let's use the rule this time. I know I went a little bit like, I call that like slow motion on the first problem. I didn't use the rule. But on the second problem, I want to use the rule. So I'm going to give us a little space over here to do the second problem. Negative 3 raised to the 7th, negative 3 raised to the 4th. So I'm going to keep the base. What's the base? Negative 3. And I'm going to raise it to the power of, we got to subtract 7 minus 4, which is 3. So this is the answer to that problem. And if it says to expand, you should expand. It doesn't always say that. But I just want to show you how you'd expand. I mean, you just do negative 3 times negative 3 times negative 3. We know negative 3 times negative 3 is 9 positive. So this whole thing comes out to negative 27. When to expand and when not? Well, I think, in my opinion, if it's to the second or the third or maybe even the fourth power, you should expand it out. It seems like it's okay to expand it out, or if they ask you to. But if it's not, then you probably don't need to expand it out. If it's to a much higher power, if they don't ask you to, you don't really need to expand it out. So hopefully all that's making sense. We're going to move on in just a second. Hopefully you are with us. Yes? So on this page, I want you to try to like just do these as a now you try. So I want to just look at a couple of these and think of these as a now you try. So I'll put the official now you try here. And I'll tell you which ones I want you to try. I just want you to try 1, I want you to try 3, and I want you to try 5. So pause the video as you're working and try to give those 3 problems a shot. Pause the video, give them a shot. You don't have to expand them out. All you have to do is keep the base and subtract the exponents. So pause the video and see what you can do. So I hope you paused the video and gave these a try. I just do want you to do on this number 5 right here, I want you to expand that out. So whatever you get for an answer, I don't want to have an exponent in it. I want you to actually do out the exponent, if there is one, when you get a solution, okay? So try to expand that out, okay? So that's what's happening on number 5. So hopefully that made a lot of sense. We're going to move on from there. Okay, so that's how we work out the quotient of powers, division of exponents. So I want to kind of take you to the next page and talk to you a little bit about the basic idea. Here's the big idea, is that when you are dividing powers, and you don't necessarily have to write this down, but it might be good to at least show this right here. This is the official algebraic rule. Okay? That might be good to write down, so please copy this down if you're watching the video. And also, I'm just trying to help you to understand that all you're doing is keeping the base, which is a in this case. A is the base. And you're subtracting the top minus bottom exponent. Okay, so top minus bottom exponent. And that will always work. But what would you do if the bottom was bigger than the top? That's going to get a little weird. So let's talk about that for a second. Okay, you're right, you would get a negative, I guess. So let's try to do a new example. Example is this. Let's say we had 5 to the second over 5 to the 8th. Or actually, I'll make it 5 to the... No, I think 5 to the 8th is good, actually. Sorry. 5 to the 8th. Or even, I'm going to make it 5 to the... 5 to the... I can't make up my mind here. 5 to the 3rd, okay? Okay, so what do you think 5 to the second divided by 5 to the 3rd will come out to by the rule? What does the rule say? Shh. What does the rule say? Rachel?
Like, what's the answer?
Yeah, what do you think the answer would be? 5 to the negative 1? 5 to the negative 1 is correct. That's actually the answer. But I want to talk to you about what that means. What the heck does that mean? Well, let's look at it in expanded form. So if we just do this out in expanded form, what's 5 to the second? 5 times 5. What's 5 to the third? 5 times 5 times 5. So now, how many can I cancel out? How many can I get rid of? 2. So I get rid of this and this, and I'm left with a 5. Is the 5 in the top or in the bottom? The 5 is in the bottom. So 5 to the negative 1 means that there is 1 5 in the bottom. Kind of weird. Let's talk a little bit about negative exponents before we get into solutions that come out to negative exponents. I'm going to draw a pattern on the board, and I want you to see what you think of the pattern. And I want you to copy this pattern down. So here we go. It's pretty simple. 2 to the 3rd power, I know pretty quick, is 8. I know 2 to the second power is 4, and I know 2 to the first power is 2, and I don't know what 2 to the 0 power is. I've never taught you that. But I could probably tell you what 2 to the 4th power is, right? 2 to the 4th power is what? 2 to the 4th power? Thoughts on that?
Can I go to the bathroom?
Not right now. Not the second. So 2 to the 4th power, what's that going to be? Yep. 16, perfect. So there's the answer. Those are all the answers, okay? So now I want to ask you, Anthony, if there's a pattern here. Pattern going down. So as I did this, how did I get there? Yes? Yeah, divided by 2 is correct. 16 divided by 2. 8 divided by 2. 4 divided by 2. So what is 2 to the 0 power? Don't take the pattern for granted, okay? Don't take the pattern for granted. What do you think 2 to the 0 power is going to be? Anybody? What do you need to do by the pattern? Divide by 2. What is 2 divided by 2? 1 is the answer. 2 to the 0 power is 1. What do you think 5 to the 0 power is? 1. What do you think 8 to the 0 power is? What do you think 9 to the 0 power is? What do you think negative 2 to the 0 power is? Yeah, but negative 2 if it's in parentheses, right? So negative 2 to the 0. So what I'm saying is anything to the 0 power, okay, is going to equal 1. Why, though? Not because I said so, but because of this pattern, right? Does that make sense? Let's try to continue the pattern a little bit further, okay? So if we continue the divide by 2 pattern, I'm just going to keep going divide by 2, divide by 2. So I'm going to divide by 2. I'm going to divide by 2. And I'll divide by 2. So let's think about what would happen here. So we got these answers. They're going to be here. 2 to the what, 2 to the what, and 2 to the what. What is this? So we got 4, 3, 2, 1, 0, 2 to the, what should that be? Well, look where we were at, right? We had 4, 3, 2, 1, 0. So what should this be? That should be negative 1, shouldn't it? That should be negative 1. If that's negative 1, then where should we go from there? If this is negative 1, then where are we going? Right here, shouldn't this be negative 2? And this should be negative 3, right? Yeah, don't skip over, right? So now the question is, what's 1 divided by 2? We're doing the math out. 1 divided by 2 is 1. I'm just going to write 1 divided by 2. What's a half of a half? What's 1/2 divided by 2? 1/4. Because you're making it smaller, right? You're taking a half of a half. 1/2 cut in half or divided by 2. 1/4, 1/8. Now I want to ask you one more question. Do you see the numbers that are down in the bottom, the denominators here? So I'm going to highlight some things. You guys see this number here is an 8, and this is a 4, and this is a 2. Can you look at the pattern for a second and tell me if those numbers look at all familiar? The 8, the 4, and the 2. Have you seen them before?
Yeah.
Where do you see them on the screen? So you're telling me that this right here is a 2, this right here is a 4, and this right here is an 8. Do you think that's a coincidence? Do you think it's a coincidence, or is that for a reason? It is for a reason. Because what's happening is when you have 2 to the negative 2, right, it's exactly the same as 2 squared, but it's in the denominator. 2 to the 8th, right, if we had 2 to the 8th, and we knew what 2 to the 8th was, which is a pretty big number, we got to take 16 and multiply that by 2, so that's 32. Right, we got to take that and multiply that by 2, that's 64. So this is 2 to the 5th, 2 to the 6th, 2 to the 7th, which is 128, and 2 to the 8th, which is going to be 256. 2 to the 8th is 256. What do you think, if 2 to the 8th is 256, what do you think 2 to the negative 8 is? What do you think 2 to the negative 8 is? I put a fraction line as a little hint. Yes?
You wrote 252.
Oh, my apologies. 2 to the 8th is 256. What do you think 2 to the negative 8 is? Jump in. What do you think? Anybody? Yes? No, because when we did the negative exponents on the left side, when we did that over here, we didn't actually get negative answers. We actually just got fractional answers. Yes? Exactly. It's 1 over whatever 2 to the 8th was. 1 over 2 to the 8th, which is 1 over 256. This is the pattern I was trying to show you over here with the green highlighter. Okay? This is what happens with negative and 0 exponents. They wind up in the denominator. It's not really as simple as that, but that's a pretty quick way of explaining it. It's going to have something to do with that. Okay? So I think we're starting to run a little out of time here. So I just wanted to give you a brief understanding of 0 and negative exponents and help you to get the gist of what they meant. So let's talk maybe about just a couple of problems here. Maybe real quickly we could look at, let's say we looked at this problem here for a second. Whoops. Here. So why don't we just try one problem, one more problem, this guy. 2 to the 6th divided by 2 to the 8th. What does the subtraction property of exponents say? It's 2 to the what? Where do you have more? In the top or in the bottom? If you have more in the bottom, when you cancel them out, where are they going to wind up in the end? In the bottom, don't you agree? So don't you think that the top part is going to cancel out to just a 1? There's not going to be anything up there, but there needs to be a 1 as a placeholder, right? Because it's really like 1 times whatever's there, 1 times whatever's here. The reason that you put a 1 there is because it's 1 times 2 to the 6, right? Well, because 1 doesn't change anything, does it? So when you cancel everything out, you can't have a fraction just totally empty on top. You have to have a number there. Whether it's a 0 or not, or a 1 or a 5, whatever it may be. But if we're looking at this problem right here, 2 to the 6, we could put a 1 in, that's fair, right? What about 2 to the 8th? Well, we could put a 1 there if we wanted to. We also don't need it in this case. So I'm going to put 8 2's there, right? How many are going to cancel out here? 1, 2, 3, 4, 5, 6. How many 2's are remaining in the bottom? 2 2's are remaining in the bottom. These are, by the way, all multiplied. So we have 2 times 2, which is 4, or 2 to the 2nd. But we notice that there's nothing left on the top except I knew the answer, and I put a 1 in the front. Do you see what I'm saying? Because I can't put nothing, I don't have nothing up there, because otherwise the whole answer is 0. So I have to have a 1 with everything. I have to have something there. So the 1 goes there. The invisible 1, as you see so often in math. So this is the answer, 1/4. So we'll stop the video there. Hopefully that made a lot of sense to you. We'll work more with these as time goes on. I'll see you in the next video. Peace.